Okay, hello, good morning everyone. So I'm sorry because today I'm late, unable to upload also the video because I am testing for the YouTube live. Unfortunately I can't able to do that. Okay, the remaining portion of the yesterday's problem, that is for the BBS of the two-way slab, we have completed the section AA. I hope you can able to understand the BBS of two-way slab. Here is the previous problem. I am repeating some portions. It is a two-way slab. The dimensions are in one side 5 meter, another side 6 meter, and the sectional cross-sectional area of each side, that means A direction and BB directions, are shown in this figure. This is the AA direction and this is BB. I have completed all the calculations regarding the section AA. If you can't able to understand, please ask me. And for section BB, this is the total detailing of section BB. Now there are three kinds of reinforcements are there. This portion is called the bent up bar, and this is the bottom bar or straight bar, and these bars are called the top bar, right? So these three kinds of bar I have to estimate. Okay, here you can see this page I have been added in the PDF. Okay, so the first type of bar, that is bent up bar. So in bent up bar, first I have to calculate the number of bar. Okay, so how to calculate the number of bar? The number of bar is simply I can calculate by the using this formula. This is nothing. Actually, if you see the previous diagram, this is the diagram. This is the diagram. If you see this diagram, suppose you need to calculate number of bar 5000 by 100 into plus 1, sorry. So this 100 is nothing but the spacing, and where is this bent up bar is located? This bent up bar is located in this manner, right? So if you need to calculate the bent up bar and alternate bent up bar, I use this dimension, right? So this dimension is nothing but the 5 meter. So 5 meter by the spacing, 5 meter by the spacing, I can calculate the number of bars, right? So here that is calculated 5000 by spacing plus 1, because I have to end up with a bar, so 51. Now if we equally divide it, that is I am taking one extra for crank and one less for straight, because it is even odd number. So that's why I am taking crank bar 26 and straight bar 25. Now I have to calculate the length of the bar. This is nothing, simply 6000. Why it is 6000? Because you can see over here that this length is the inside to inside, the length is 6000. Then I have to add this inclined portion, that is for 0.42D for each side, and LD each side. LD each side. Okay, 1 second, I have to remove I remove all these things. Yeah, so the clear distance, that is 6000, 2 inclinations, that is 2 into 0.42D, 2 LD, and bent, and the bent portion, that means here 45 degree, here 45 degree, here 45 degree, here 45 degree, here 190, here 190. So that's why you can see over here L dash plus crank plus LD minus bent. Now bent is minus 4 into 1D, because 45 degree angle it is 1D, and 2D for 90 degree. So here you can calculate the 7.22 meters. Similarly, in straight bar I can calculate L dash plus LD. What is L dash? You can see the diagram over, and 6000, and 50D is the development length, right? And what is D over here? D is the diameter of the bar. Nothing, I think most probably it is 12, and it depends on the grade of concrete and grade of steel. You can see the formula regarding the development length, that is in IS 456/2000 is already given. And we have total, okay, I missed out in this particular thing. To calculate the total length of bent up bar, you just multiply with the number of bar to the single length of a bar. Okay, in straight bar you do the same thing over here. 7.2 is the length of the single straight bar, you multiply with the number of bar. In top bar, here is the important part to calculate the length of top bar. Top bar, what is given here? Look, first I have to calculate the number of bars. Okay, just see the diagram where the top bar is located in section BB. Here is the section BB. How much time is remaining? Okay, section BB. Look, these are the top bars 1, 2 and 3. Actually this is visually, but number of bar will be actually calculated by using the formula. Yes, then if we want to find, the bars are placed like this, right? So if we want to find this number of bars over here, I have to use this dimension, right? From this dimension I have to subtract this L dash by 5 distance, this L dash by 5 distance, both side, right? And then only I can get the number of bars in this area. Actually I am not subtracting that L by 5, I will use only the L by 5 distance, because only in L by 5 distance in both these sides these bars are located. So what is the value of L by 5? I can see in the here, look, the L by 5, this is the 6000 and this is the 5. So L by 5 by spacing plus 1, because I have to end up with a bar, and into 2. Why into 2? Because look, this number of bars is also present in these sides also, that's why I have to multiply with the 2. So I can get the number of bars of this top bars. Now you just I need to find out the length. Now how to calculate the length? Length is very much easy. Then I have to use this distance. Simply I have, this is L by 5, here also L by 5, I just need to find this distance. Very much simple. The total distance L is 5, so I just need to subtract here 5 by 5, here 5 by 5, that means 3. It will come around 3, but I have to put some extra distance, because if you see here, if you put here only if you put the bar only dimension of 3, it can't float like this here. So you have to provide some extra distance both side. This extra distance is I am taking 100, okay, in both sides. So you can see the diagram. So you can see the calculation. 5000, 2 into 5000 by 5, that means both side, and 2 into 100, that means both side. Okay, I will show in the diagram. Look, total is 5000 minus 2 into 5000 by 5, that means in this both sides is deducted, and adding of these two portions, 2 into 100, that is the calculation given here. Okay, so this is the length of the top bar, and you just multiply with the number of bar to the top bar, and you finally get the total length of the bar. Okay, now you just, as the dimensions of straight bar diameter, the diameter of the bars, that means the bent up bar, straight bar and top bar, all the diameters are same. You just add all the total numbers of total length of those bars, that means bent up bar, straight bar and top bar, and you will get a certain value, and you just divided that with the standard length of a bar. A single bar is around 12 meter, right? So you just divide that with 12 meter, you finally get the number of bar. That means you go to the shop and you just ask that this much number of bars I will need. So finally VBAC is completed for 2 years. Thank you.